Hello friends, now we will move on to the second question. Utility A would sell electric power in a future month because it currently has no sale contracts in place. This utility would use put options to protect itself against a possible decrease in the price of electricity. Utility A would purchase a 200 megawatt hour put option contract from utility B with a strike price of $20 per megawatt hour and a premium of $2 per megawatt hour. At the expiration, part 1 of the question is, if the future price drops to $16 per megawatt hour, determine the profit or loss of both utilities. The second part is, if the future price increases to $24 per megawatt hour, determine the profit or loss of both utilities. Third part of the question is, what is the maximum loss and maximum profit of utilities A and B? This question is with respect to the variable spot price. That means at what spot price this happens, we have to find that, and accordingly the corresponding maximum loss and maximum profit should be found out. Now the fourth part of the question is, plot profit and loss of utilities A and B against the future price. Future price in the sense spot price, the future spot price. Making it as a variable, you have to plot the profit and loss of utilities A and B. Now we will move on to the solution. Okay, now utility A purchases 200 megawatt hours put option at $20 per megawatt hour with $2 per megawatt hour premium. Now it says that the future spot price is 16. So put option is right to sell. Selling at 16 is a loss compared to selling at the strike price 20. So definitely the holder of the option will exercise the option. But for exercising it, we know that he has already paid the premium for the agreement, which is 2. So 2 into 200 would be an expense for the holder. Then 20 minus 16 would be the profit from the relative profit compared to the spot price and the strike price. So 20 minus 16 and an expense in premium is minus 2 into 200. So 20 into 200 minus 16 into 200 minus 2 into 200. So the profit of utility A is 400, and this 400 is received by, now this 400 is given by utility B. So the loss for the corresponding loss for utility B is 400 itself. So this is the loss of utility B, $400 per hour. Now in the second part of the question, it says that the spot price has increased to $24 per megawatt hour. At $24 per megawatt hour, the holder will not exercise it because the spot price is more when compared to selling at spot price is better when compared to selling at the strike price, even though the premium is also considered. So now if he doesn't exercise it, his only loss is with the premium, and $2 is the premium. So for 200, 2 into 200, $400 per hour is the premium lost. I mean the total amount lost in terms of in the head of premium. So the loss of utility A is 400, and this amount is received by utility B. So the profit of utility B is 400. Now to find the maximum loss of utility A and utility B, we need to draw the plot for variable spot price. Let us see what is happening there. Now the minimum spot price is 0, right? Minimum spot price is 0. At some amount you are going to stop it. Here it is drawn till 42. Beyond that also we can draw, but this is a constant. So I mean the profit of utility and utility B is finally reaching a particular value, and beyond a point it is a constant. So if it is more than 42 also, the same characteristic will continue. So we have now drawn till 42. Now you can see here, first we'll see the profit of utility A. Profit of utility A, you can see here the break-even point is 18, because if 20 is the strike price and 2 is the premium. Then 20 minus 2 is 18. So at spot price 18, it is a no profit no loss um, uh, plan for the utility A. Um, no profit no loss price for utility A. So here it becomes 0. The profit becomes 0. Beyond this point, it is a loss for utility A, and that loss is still 20 only, because this $2 premium is also covered here. Then after beyond 20, he will not exercise it. Utility A will not exercise it. If he does not exercise it, his loss is only premium. So that is 2 minus 2. That means profit is minus 2, that is loss is 2. So then it is a constant. He will not exercise for any price beyond this particular point. So this is the profit curve for utility A. Now for this particular, this constant characteristic for the corresponding, for this constant characteristic of utility A, there is a corresponding profit for utility B, because this is a loss for utility A. There is a corresponding profit for utility B. So beyond this point, it is a profit for utility B, and it is the same amount, which is 2. Here it is minus 2, here it is 2. Okay, and the break-even point is same. Now to find the, what is the third part? In the third part, it is also, you are also asked to find the maximum loss and maximum profit. So what happens here? The maximum loss of utility A is $2 per megawatt hour, because here it becomes constant here, right? It becomes constant here, $2. Maximum loss is $2. Now the corresponding profit is profit for utility B is $2. So the same thing here. The corresponding maximum profit of utility B is $2. Maximum loss of utility A is $2. Now the maximum profit of utility A, that happens at the spot price 0. What happens at spot price 0? At spot price 0, the strike price is 20 and 2 is the premium. So 20 minus 2, 18 is the profit for utility A. The corresponding loss for utility B is minus 18, right? So that is what. Now here you can see the maximum profit of utility A is 18 and maximum loss of utility B is 18, or maximum profit of utility uh, B, or minimum profit of utility B is minus $18 per megawatt hour. That is what we get. Now this is the in the fourth part of the question, you are asked to draw the profit loss characteristic of utility A and B. That is what is drawn here. Now we will move on to the next question in the next session. Thank you.